Hi, welcome to lesson 13a, problems involving vector operations. The goal of today's lesson is to determine how to find the resultant vector when two forces, or two different vectors, are acting upon an object. So we know that there are vectors in our world. Some of the vectors could be a vector of wind, for example. It could be a vector of current. Again, over to the right. It could be the vector of a plane flying. Could be the vector of a boat or a canoe, some sort of thing like that. So there's all kinds of vectors that can be combined, and the majority of the ones we're going to be looking at in this section are vectors of planes and wind as they combine with each other, and boats and currents as boats cross rivers. Okay, so there's going to be fairly simple situations where we look at, for example, in this case, an airplane traveling, I guess we can call this east, 500 miles an hour, and the wind is blowing west at about 100 miles an hour. Then the resultant speed of the plane with respect to the ground is going to be 400 miles an hour. So this airspeed is the speed of the plane with respect to the air. The wind is the speed of the air with respect to the ground, or the earth. And then the resultant is actually the ground speed of the plane, which is the resultant speed of the, or velocity of the plane with respect to the ground. Okay, so we're going to be looking at some sort of scenarios like that. So that's one of the more basic ones. Then if we look at one a little bit more complicated, suppose the plane's velocity, again with respect to the air, 100 kilometers an hour south in this case. The wind velocity in this case is 25 kilometers an hour, and that's the air movement with respect to the ground, or the earth, moving west. And then when we add these two vectors, we add the two vectors head to tail. So here's the plane's vector here heading south. Here's the wind velocity, or the speed of the air traveling with respect to the ground, going west at 25 kilometers an hour. Then the resultant velocity of the plane with respect to the ground then is going to be this diagonal here. So we complete this triangle of the plane velocity plus the wind velocity equals the ground velocity of the plane, the resultant velocity. And in cases like this, where the velocities are at, or the plane and the wind are at 90 degrees to each other, then that's just a simple matter of using Pythagorean theorem, using these two velocities to find the resultant velocity there for the hypotenuse. We could, of course, have situations where the plane and the wind are not at 90 degrees. Same sort of idea. The airspeed of the plane with respect to the air traveling this direction. The wind velocity, of course, the speed of the air with respect to the ground, going in this direction. And then the resultant velocity, we can see that the wind will be pushing on the plane. So as the plane is trying to go in this direction, the wind is pushing it in this direction, and therefore it ends up in this direction. Over here, the resultant ground speed of the plane with respect to the ground. So, and it's not that the plane is going in that direction and then the wind pushes it suddenly all in that direction. This is just a simplification of the situation. Strictly speaking, the path of the plane would kind of be in an arc. It would kind of be going like this, being affected by the wind the entire path. So it would kind of fly in an arc, ending up over here. But for simplification, we've got the triangle formed here. Then, of course, if we have a current in a river and a boat trying to cross the river, well, here is the boat's, we see the boat's direction is heading north here across the river. This is the boat's velocity with respect to the river, it says BR, the velocity of the boat with respect to the river. Then here is the velocity of the river with respect to the earth. So that's like kind of the current, the water current, flowing downstream. And that's heading east. And then so the resultant velocity of the boat is, again, on an angle, the velocity of the boat with respect to the Earth. Or again, the ground velocity, as we can call it. And again, like I was saying with the plane, the path of the boat won't be direct like that, but it's a simplification. The path of the boat would kind of be an arc. As it struggles to go perfectly north, the current pushes it towards the east, and it gradually ends up over here. Okay. Again, in this case, 90-degree angle, Pythagorean theorem, the resultant velocity would be the hypotenuse there. And here's a situation where the boat is starting over here, and it wants to end up directly across the river. So it's going to go, the boat's going to steer in the direction upstream of the current. So here's the boat with respect to the river. The velocity is going sort of northwest. And the current is going to be pushing it towards the east. And so the resultant velocity of it is basically straight across. So again, it's going to be kind of curved as the current pushes on it, but it gets, the boat ends up directly across from its starting point as it wishes to go, because it's steering in the direction of the current to sort of compensate for that pushing east of the current against the boat. Okay, and this resultant would be then the ground speed of the boat, or the speed of the boat with respect to the Earth. So one thing that's going to be very important as we look at some examples tomorrow is there will be some situations where we're given all velocities. Sometimes we'll be given a velocity and a distance. The important thing about these diagrams, these vector diagrams, is all the units have to be the same. So if we're going to set up this diagram here, we have to make sure that we're using velocities on all the sides of the triangle. If we're given a distance and then the speed of the river, we're going to have to know time to convert this side of the triangle into distance. So we've got distance, distance, and then use this distance. Okay, or find that distance before we start finding the speed. So all the relative units have to be the same in order for all this to work. Okay, so we'll be looking at some of these things tomorrow in class. In the meantime, take a look at some examples in section 13a, and then peruse some of the referred or the suggested homework questions, the practice questions, tonight before coming to class, so you have a sense of what's going to be asked of you tomorrow in class. So thanks for watching, and we'll see you in class.